Now let us discuss this problem. This problem 1.44 from Irodov. So you draw the diagram and then we will discuss. You can leave this diagram, this part you can leave. Let us find this diagram. Let us show this diagram. Now you see what this problem says. This problem says a wheel rotates around a stationary axis so that rotation angle phi varies with time. So I have a stationary axis and this wheel is rotating around this stationary axis. There is some point A on the wheel. So this means this point is sometime here, 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 here. So if I say initially the phi angle is 0, after some time we will have some phi. So after some time we will have phi. Here we have another phi, phi, phi. So phi keeps changing. So initially if I measure the phi with the y-axis, initially this phi, after some time this is the phi, after some more time this is the phi, after some more time this is the phi. And question says phi varies with time with a given equation phi is equals to AT square, where A is some constant. Now question also asks find out the total acceleration after time t, where t is t naught, v is v naught. So we have to find acceleration. Now we know acceleration basically have two components. If the motion is in circular orbit, we can say radial acceleration and tangential acceleration. So AR denotes radial component of acceleration. So this is radial one, and AT denotes tangential one. If you remember, tangential acceleration is nothing but dv by dt, and radial acceleration is nothing but v square by r, if you remember. Now you see, I can find phi is given, we can find d phi by dt. So phi is AT square, so d phi by dt is simply 2AT. We have to find at time t is equals to t naught. So this will become t is equals to at t naught. So this will become 2AT naught. Now this is given at time t is equals to t naught, v is equals to v naught. And so what is omega? So this is d phi by dt is omega. So this is moving in a circular path, so I have to also verify v is equals to r omega. Now v I can find from here. V is given v naught. In question, when time is equals to t naught, v is given v naught. And v naught I can also find. This is to equal to r omega. R, and omega is nothing but 2AT naught. So from here I can find basically what is A. So A is nothing but v naught by 2r t naught. This is not acceleration, A is a constant. Basically this constant value is given. So I can find what is the value of v naught at this point of time. V naught is given or not? V naught is also given. T naught is given or not? T naught is not given. T naught is also given. So what we can find? So A is also given. T is also given. T is equals to T naught. And at this moment V is also given, V naught. This means I can find R. Radius is not given in the problem. So from here A is given in the problem, V naught is given in the problem, T naught is given in the problem. If you see the book you will find. So from here radius is V naught by 2T naught A. A is given in the problem. Now so this means radial acceleration is, now I know radial acceleration is velocity at this time, that is v naught square by 2 v naught square by r. So this is the radial acceleration, everybody knows. So v naught square by r, so value of r is v naught by 2r, here v naught by 280 naught, v naught by 280 naught. So this will becomes 280 naught v. So this is 280 naught v naught. This is the value of v naught square by r. Now what is the tangential acceleration? Tangential acceleration is dv by dt. Now this is a circular motion, v is equals to r omega. I can also write this divided by dt. I can take r outside. So this is d omega by dt, and d omega by dt I can find from here. So this is omega. So omega is 2a-t. So d omega by dt is simply 2a. You see, d omega by dt is 2a. So this becomes 2ar. So this value is 2ar. So what is the total acceleration? So radial component of acceleration I know, and tangential, this is the radial and this is the tangential. So total acceleration is root over 2a-t naught v naught whole square plus 2a r. What is the value of r? R is nothing but v naught by 2t naught a whole square. So this will be the value of total acceleration. You can take the things common and you will find the. So let us do some simplification. So if you do some simplification, you will get the answer. Let me do this simplification here on the next page. So if I do simplification, you can do this one your own. Now I can write a is equals to v naught square. So I can take v naught as common. So v naught square, I have this is also a square because I have to tangential. So 2a square r square. So 2a square is also there. 2a square here also. So we can take 2a common. Now t naught a square here also have. So what will remain? 2a v naught is common. So t naught a square here I will have. Now what is the term we will have here? We will have 2a v naught we have taken. So 1 by e. So this will be 2t naught. So 4t naught a square and then a square. So this is the, you check the answer, you will get the same thing I think. So this is the total acceleration. So if you take t also outside, 2a v naught, so this will become, if you take t naught a also outside and 2 also outside, so this will become, so 4 t naught 4 a square plus 1. Now 2 t naught a is outside. Now a cancels out. So we will have 2a 2a, so v naught by t naught. Now simply I will have v naught by t naught 1 plus 4a square t naught square. So you see, this is the answer. Are you getting or not? So this is simply simplification. Rest of the part is mathematics. Only one thing is important, and the point is, you see, you have to look for total acceleration, that is radial acceleration plus tangential acceleration. So you have to square them up and then take root, then you will get the total acceleration. Tangential acceleration is dv by dt and radial acceleration is v square by r. Since theta is varying with time, I can calculate omega, and if I know the omega, I know the v is equals to r omega. So at any time we know the v square by r. So similarly you find other things and I will solve this problem. We will discuss the next problem.